Hello and welcome to a video on vacuum chucking systems by Robust Tools. Let's start with an overview of our complete kit. We have a two-stage 4 CFM oilless pump. There's a hardware kit that includes all your hoses and a filter, and there are three chucks, a 3¼ inch, a 4½, and a 6 inch. This is available as a complete kit, or you can buy all these components a la carte if you want to build your own system. All robust vacuum chucks are machined from solid 6061 aircraft grade aluminum, and they feature a flexible 3D printed seal. Vacuum chucking works by removing air pressure from part of a system so that the ambient air pressure can work against the workpiece and hold it onto the chuck. Your vacuum chucking holding power depends on several things. One is the ambient air pressure. How big is your chuck? And what is your capacity of your system to generate a good vacuum? Ambient air pressure is going to depend a lot on your elevation. Down at sea level, you have 14.7 psi helping you, but you get up to elevations like at Santa Fe, you drop down to about 11. All things being equal, the bigger the chuck, you have more surface area and more holding power. Our small chuck, 3¼ inches, will give you about 45 to 85 pounds. Jumping up to our 4½, you'll just about double your surface area, so you're at 85 to 170 pounds. And our big chuck at 6 inches can get all the way up to 320 pounds of holding power. Some other things affecting how well your vacuum system is going to work is the capacity of your pump, and are there any leaks in your system, including wood porosity. Let's look at the hardware setup that you get if you buy your system from Robust. We start out with a quality gauge so that you can know how well your system is performing at any given point. There's an inline filter to keep dust out of your pump. There's some heavy-duty reinforced hose to connect everything together. All your hardware components, including hose clamps, etc., and your ball valve, more about that later. Some Teflon tape to make sure everything goes together without leaks, and a set of instructions. Here's the hardware kit and pump fully assembled. One way to do a quick check on your system is to simply hold your finger over the end of the hose. In this case, I've got a vacuum adapter already installed, so I'm testing the whole thing. And you can see that the vacuum gauge is moving, and in this particular setup, it's going over to about 25, 26 inches of mercury, which is what I would expect at our elevation. I'm also demonstrating how the ball valve is used to bleed off vacuum, and we'll show how that's useful in just a little bit. Now, this is the rotary adapter that is applicable to robust lathes and to Powermatic 3520s. I'm going to put a little petroleum jelly on the O-rings before I insert this. You can also use grease or other light lubricant. To use this style of adapter, simply slip it into the end of the spindle. There are 4 seals inside the housing that prevent vacuum leakage. When you turn on the lathe, the housing will spin, but the hose will stay stationary. When you're done, just simply pull it out. If you don't have a robust lathe or a Powermatic 3520, we've got a different system, and we'll show you that in just a little bit. Well, let's move on to some actual vacuum chucking. This is a natural edged cherry piece that I turned. I've sanded the inside and I've rough turned the outside. I'm going to leave it on the chuck, and I'm going to show you a reverse chucking technique. I'm going to use a chuck adapter. It's threaded 3/4 10 on the inside and 1¼ 8 on the outside. And I'm going to put that right on my live center. Any live center threaded 3/4 10, you can use one of these chuck adapters. And now I'm going to screw the chuck onto this end of the lathe, and I'm going to install my vacuum chuck. And then I'm going to slide the tailstock up and have the piece make contact with the vacuum chuck. I'm going to turn on my vacuum, and then I should be able to unchuck the piece and pull the tailstock away and have the piece be fairly well centered onto the vacuum chuck. For added support, I'm going to use my live center, but I don't want this sharp point. So the robust live center is built so that I can take this point out and I'm going to turn it around and I'm going to bring the flat end and have that stick out of the live center just a little bit. And that flat end is going to support the work and I won't be leaving a mark on the bottom of my piece. You'll see I've got a little circle drawn on the bottom of the piece, and that's dead center. And when I bring my tailstock up, you'll notice that that circle is not running concentric. So what I'm going to do is I'm going to use that ball valve that I showed you earlier, and I'm going to bleed off almost all the vacuum, and that'll allow me to shift the piece just a little bit and get it repositioned so that this base is running true. It may take a little fussing around, but it's worth doing. After I've got it running to my satisfaction, I'm going to bring the live center up to the work so that it's just touching, just enough to make the live center spin. It doesn't need to apply any real pressure. The vacuum's doing that. But if there was any kind of compromise in the system, the live center would help provide some support. Well, now we can get busy and turn the base. The thing to keep in mind here is that you just want to take light cuts. If you get too aggressive, you could throw the piece off of the chuck. This piece is going to have a recessed base, so I've turned away almost all of the tenon, and I've started my sanding. I wanted to show you how the vacuum will draw sawdust into the wood on the end grain and not very much on the side grain. This can affect your finish, and I wanted to make you aware of it. Some things to mitigate it are frequently blowing off the sawdust, and then also when the piece is finished, taking your compressed air and blowing it from the backside. Now to finish the base, I've pulled the tailstock away, and I'm going to take really light cuts. It's important to know how thick your piece is at this point because you don't want to poke a hole through it, lose your vacuum, and have the piece come off of the lathe. So far, we've been doing our turning using the vacuum adapter built for robust lathes and Powermatic 3520s. If you don't have one of those lathes, you might consider our vacuum chucks with built-in vacuum adapters. And we also have a universal hub that can accommodate the built-in adapter. I'm going to show you how to set up our universal hub, and then we'll also demonstrate the built-in adapter. So I'm going to use the universal hub to build a vacuum faceplate. I'm going to start by using a hole saw to put a 2-inch hole in a piece of MDF and then sawing it into a circle on my bandsaw. I'm going to apply a little silicone and then I'm going to put the hub into the hole and screw it in place. If you get a unit with an adapter, you also get a piece of tubing, and I'm going to install that now. And then the tube just slips through the spindle and you screw on your chuck or universal hub. Here's the easy part. You just take the hose from the vacuum pump and slip it over the tube. You don't need to install a hose clamp. The vacuum will hold it in place very securely. And you'll see when we turn the lathe on that the tube just hangs out there in the spindle hole. Now I'm just going to clean up the edges of the MDF and break the sharp corners. I'm going to use some closed cell foam packing material for the gasket on this faceplate application. Be sure to cut a hole in the center for your vacuum to be drawn through. You'll notice that this is not glued on, just taped. I don't like to glue it on because as the gasket material begins to fail and wear out, it's hard to get off. A couple of pieces of tape is all you need to hold it in place. The piece that I'm going to turn here is a piece of ash, and I've already got a center hole mark from my original turning. And I'm going to use that on the point of the live center to locate this onto the faceplate. I've got the flat end of the live center tip exposed again to support the work. Watch what happens when I increase the vacuum. The gasket compresses and the wood deforms a little bit, pulling it away from the center. So I'll bring the live center up until it's just making contact, and then when I start my cuts, they'll just be light cuts like before. I'm going to make the final shaping cuts with a spear scraper. This is really great for refining the shape, and if you do it right, you get really nice, beautiful shavings. Now I've pulled the tailstock away so that I can refine my recessed base, And then I'm going to add a couple of little decorative grooves just for fun. We're all done now, and we can take the piece off of the faceplate. And you can do that by either opening your ball valve or just turning the vacuum pump off. Be sure you got a hold of it because it's going to fall on the floor if you don't. And there you have it, ready for finish. Let's go over a few of the pros and cons of vacuum checking. Well, the cons are it's expensive to get started, and you're going to be restricted to light cuts. You can affect the finish on porous woods, and voids or holes must be plugged. On the plus side, on the pro side, you have really quick setups. You can do multiple sized work on the same chuck. You can easily hold natural edge pieces. You can finish the base without tailstock interference. And we didn't cover this, but you can remount finished work. Speaking of finished work, here's the two pieces that we made here in this video. I did put some dye on that ash piece, and I think it turned out really nice. Hey, thanks for watching this video on vacuum checking. If you have any questions, give us a shout.